Hello everyone, welcome back to this review. So this is going to be our part 3 of this review. So let's go ahead and begin by analyzing this graph and answering one of the few characteristics that we see. So go ahead and answer this question. So hopefully you were able to see that, hey, I have this function, and hopefully you can see that, hey, there is an asymptote right here. There is a vertical asymptote right over here. And I can go ahead and tell you that that is going to be on 1, 2, 3, 4 at x equals -4. And we have a removable discontinuity right over here at x equals -2. So go ahead and pause the video, give that a try. Okay, so we also can see that we have a horizontal asymptote right over here at y equals 0. So from here, we have a vertical asymptote at x equals -4 and a hole, also known as removable discontinuity. So let's go ahead and see what we can answer. Now, we have this -4 right here, and we're going to go ahead and see what the first one tells us. That we have an infinity discontinuity, well, infinite, that's also referring to a vertical asymptote at x equals -2. Actually, no, we don't. We have a hole, so not this one, so not A. Okay, we have a removable discontinuity at x equals -2. That might be an option. The function has a removable discontinuity at x equals -4. That is false. We actually have a vertical asymptote at x equals 4. And we have a jump discontinuity at x equals -4. Unfortunately, that's not true either. So hopefully you were able to see that this is B. Okay. Multiplicity, guys. Keep in mind, when we talk about multiplicity, we have some sort of function, and that is the exponent associated with that factor. So at x equals c, if this number right here, the exponent, if it is even, touches. If it is odd, it crosses the x-axis. Okay, so this one's not asking us if it crosses or touches. This one's just asking us, what is the multiplicity? What is the exponent here? Given that this right here. So at this x equals 2, we're going to go ahead and move this over. So subtracting it on both sides. So x minus 2, we're going to look for it. So what is the multiplicity of x minus 2? Okay, so hopefully you were able to see that, hey, this right here is this one right here. So its exponent is 2. Okay. Alrighty. Let's go ahead and try this one right here. So I'm going to go ahead and give you a couple seconds to analyze this graph that we're given of f of x and see which one of these is true. So go ahead and look through them real quick. Okay. So hopefully we were able to see that, hey, this right here, since I see these end behaviors, this reminds me a lot of a cubic function, right? And anything that looks like a cubic function is some parent function with an odd degree. Okay, keep in mind, if the exponents are odd, like 3, 5, 7, 11, 33, any exponent that's odd, it will always behave in this same end behavior. If they're odd, I'm sorry, if they're even, then they both head the same direction. Okay. Alrighty, so we have all of this and this value right here. So just like the last example, we have that the 0 at A, since it touches, it is even. Okay, so this is what we know so far. We have an odd degree, and we have that the 0 at x equals A is even because it touches the x-axis and bounces back. So let's go ahead and look at these multiple choices. Okay, so we have the degree of f of x is odd. Oh, that's good. But the 0 is odd. No, it's not. Because that would mean it would cross at A, and it does not cross at A. It touches. B tells me that the degree of the function is odd, and the multiplicity at A is even. Okay, so this is actually might be an option. The function, the degree is odd, and the multiplicity at A is even. Yep, that's true. All right, let's go ahead and see. Check C. The leading coefficient of this f of x is positive. The multiplicity of 0 is odd. So the coefficient is positive because that cubic, this one right here, is positive since it's a just looks like a cubic. So this is actually true, but it includes more information. Okay. Now the next one says the leading coefficient of fx is negative. Well, that's not true since it would be a negative cubic, and that's not. So we are left with these two options. So the one that includes more information is the one talking about the leading coefficient. So we're going to go ahead and go with C, since it still says it's positive, and the multiplicity of 0 of A is odd. Ooh, no, it's not. I thought that said even. It's actually B. Oopsie daisy. Okay, sorry about that. It is B. Oh, that's 3 B's in a row. Okay, let's go ahead and try the next one. For these ones right here, we're trying to find where the function, this function right here, is going to be less than or equal to 0. Okay, so the first thing I want you to do is find out what are the x-intercepts. So go ahead and set each one of these parentheses equal to 0, x minus 3 equal to 0, and solve. What is x? Okay. So hopefully you were able to see that minus 1 gives me x is equal to negative 1, and plus 3, x is equal to 3. So you're probably thinking, what do we do with this? Well, we're actually going to go ahead and get a number line going. So negative 1 right here, and a 3 right over here. All right. From here, we want values in the middle. We want test values that exist right in the middle. So from negative 1 all the way to negative infinity, we can pick, I don't know, let's pick negative 10. And that's the number we're going to go ahead and use. From negative 1 to 3, what is a number that exists between negative 1 and 3? That number, let's go ahead and go with 0. That's a nice number. And any number bigger than 3, let's go with, I don't know, 5. Okay. Now, we're going to go ahead and do negative 10 together, okay? That means I'm going to get my negative 10, and I'm going to go ahead and substitute it into this function. So the function is x plus 1, x minus 3. Now, keep in mind, I pick negative 10. Your number can be different. All I care about is the sign. If the number is positive, then it means it's above the x-axis. Okay, if the number is negative, then it means it's below the x-axis. Okay, so if I substitute a negative 10 into all my x's, I get negative 10 plus 1. That gives me a negative 11, so a negative. A negative 10 minus 3 gives me another negative. So far I got negative times negative. That is a positive. So this answer right here is positive. Okay, so I want you to try the next one. What happens when I have x equals 0? So hopefully you're able to see that if I substitute a 0, I'll do it with a different number, with a different color. I got 0 plus 1, 0 minus 3. That is positive on the 0 plus 1 is 1, and 0 minus 3 is negative. So positive times negative is negative. So all of this between negative 1 and 3 is negative. Okay. Next, we have when x is equal to 5, we have that x is 5 plus 1 and 5 minus 3. Okay, so over here we got a positive, and over here we have another positive. So positive times positive is positive. Okay, so what is the question asking for? Well, it's asking when f of x is less than or equal to 0. So less than equal to 0, less than means the negative parts. So our answer should be the entire interval in which we have negative. So this right here. So our answer choice should be the numbers, the numbers -1 and 3. Keep in mind, we have this little inequality that has the bar in it. So make sure you are using with your brackets like so. So our answer is again P. Okay. Alrighty, let's go ahead and try one more. And this one refers to finding zeros of graphs. So whenever we have zeros of graphs, I want you to go ahead and think, can we factor this? Well, as much as I want to do factor by grouping, unfortunately, we cannot do that because this -10 and this -24 won't reduce to something divisible by 3, since these are even and these numbers are odd. So the next thing I want you to do is think about your P and Qs to find all the rational possibilities. So P is the factors of 24 and Q is the factors of this right here, this one. So we go ahead and factor this and we have 1 and 24 because 1 times 24 gives me 24. Another numbers that multiply that give me 24 is 2 and 12 along with 3 times 8. Oops, I'm running out of space. And 4 times 6. Okay. So according to this, all the possible zeros, we got P divided by Q and include the positive and the negative values. So in this case, all these numbers divided by the factors of 1 actually stay the same, right? Just the positive and negative versions of it. So +1, -1, 2, -2, +3, -3, 4, 6 positive negatives, 8, 12s, and 24 positive and negatives. Okay, so what we want to go ahead and do here is find out, hey, can I find a zero? Can I find a root? Well, most of us would like to substitute. Okay? So if we were to substitute, let's say, I don't know, a 1 into this and it gives us a 0, then yes, that is a 0. But I'm going to go ahead and try one. So let's go ahead and try when x is equals to -2. And I believe it's this one. When x is equal to -2, and we substitute it, it does give us a 0. But what I want to go ahead and show you is that you can also use synthetic division, which means you get all the coefficients. So 1, 3, -10, and -24. And you go ahead and use them to your advantage. So this right here will be -2. I was like, whoops, this will be 1. This will be 1, and you multiply, that gives you a -2. Then you add them, that gives you a 1. Then you multiply them again, -2 times 1 gives me a -2. That gave me a -12. And then -2 times -12 gave me a +24, like so. Okay. Now, what we're going to go ahead and see is that this right here is a factor. So everything that has a -2 should be our solution. I'm going to go ahead and show you how to find the rest of them using this. Okay. So when you do synthetic division and you find 1, you can now find the rest by rewriting it. So this was x to the third. So this is now x squared, right? Keep the coefficients, plus, since this is positive, +1, x minus, because this is a -12. Okay. And from here, we can go ahead and factor this and find out, okay, two numbers that multiply to -12 and add up to 4. Well, hopefully you know that that is a 4 and a 3. And we get to see that it must be a +4 and a -3. If we set each one of these equal to 0, we get our solutions, -3 and x equals -4, which is D. Okay. Alrighty. Last but not least is the following. If we were to be given this rational function, And you see that the degree in the numerator, let's say, is bigger than the degree in the denominator, the exponents, right? Then you should check for slant asymptotes, okay? Because you don't have no horizontal asymptotes. Okay. And the way you do that is by long division. Okay, so we're going to go ahead and do some little bit of long division. X minus 1, x squared plus x plus 1, and we have the following. What multiplies to give me x squared? So what times what gives me x squared? Hopefully you said x. And then if we distribute to both, we get x squared minus x. And I can go ahead and do my long division. This gives me 0, and x minus a minus gives me a 2x. And don't forget to bring down your plus 1. The next thing that we're going to go ahead and do is continue the same process and find out what number multiplies to this 2x. So we're going to go ahead and see that I already have an x. I want 2x, so this most likely has a 2. So 2 times x gives me 2x, and 2 times negative 1 gives you a minus 2. And we can go ahead and subtract these one last time, and we're left with a 1 plus, I'm sorry, 1 minus a minus 2, which is a 3. So we have all of this right here. We have a slanted asymptote at y equals x plus 2. Okay. All right. So the next thing we're going to go ahead and do is answer some of these questions. So they're saying, hey, we have a vertical asymptote at x equals 1. Well, if we look at this right here, vertical asymptotes, if you remember from my notes, you exist holes if the factor repeats, vertical asymptotes are in the denominator, and x-intercepts are in the numerator. So we can go ahead and see that, hey, I might have one right here, but I do have a vertical asymptote right over here. Because if I was to get this whole, x minus 1 equals 0, we get x is equal to 1. So we do have a vertical asymptote. Is there a hole? So let's go ahead and check that out by factoring the numerator. But hopefully you're able to see that, hey, we don't have horizontal asymptotes at 1/2, so we can get rid of this one. All we have to do now is find if we have an x-intercept and a hole. So let's go ahead and start by factoring that right there. Okay. So I was trying to factor it too right now, but I just remembered that the reason I made it so we wouldn't factor is because this actually does not have x-intercepts. If you go ahead and graph that in your calculator, you get to see that, hey, it does not have any x-intercepts or holes. Our solution would be A. If you do want to find the imaginary zeros, you would have to do the quadratic equation for this. Okay, so hopefully this helped. I know Unit 2 is a little bit harder than Unit 1, so that's why we go ahead and stress on some of this stuff, but hopefully this helps out a little bit. And if you do have additional questions, guys, please reach out to me and I'll gladly help you guys out. As always, guys, it's been a pleasure, and thank you.